All right, chapter 13, the Cartesian plane. Let's take a look. Okay, so we have a set of data. They're telling us that we have kind of an output and an input. Give ourselves just a blank layer to work on here. Okay, so they want us to plot the points on here. We have our x-axis here, so that's our x. So we're going to give ourselves a horizontal axis for our V, C, E, and then we're going to give ourselves a vertical axis. And obviously, if you're going to plot points, it'll be much better to plot it on with a computer that you can get exact grid marks on, or nice graph line paper. But in this case, we're going to start with our 0, 0. So this is our IC value here. We're going to go to 0. So we've got 1, 2, 4, 10. So we're going to set our values 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we're going to plot our different points. So at 0.5, so we're halfway here, we're going to go up to, we'll say that's 1, 2, 3. So 1, 2, 3. So at 0.5, we are up at 2. Then at 1, we're at 2.4. Then at 2, we're at 2.5. And then at 4, we're at 2.7. 6, we're 2.9. 8, we're 3.1. And then 10, we're at 3.3. And if we connect this, we can see it roughly curves up that way. Okay. On number 2, it asks us, with these values, calculate the slope of the line that goes through these points. So we're going to calculate just the whole process of the line. We're going to take 2 points. We're going to take to find our slope, we can say that's y 0.2 minus y 0.1 over x 0.2 minus x 0.1. Basically find the change in here. So we're going to call this our 0.1 and this one our 0.2. And so we're going to take y2, 40, minus y1, which is 20, over x2, which is 2.6, minus x1, which is 1.2. And we're going to simplify that. We'll use our calculator to solve this value. So 40, I'll put that in parentheses, 40 minus 20 for the numerator, divided by 2.6 minus 1.2. And we're going to just round our value to 2 decimal places. So we have 14.29. Okay. So this is our slope, which we can also call m. And this is the value we're working with. All right, our next problem. We want the equation of the line that passes through these. So realizing these are the same values, we can use that slope value. And we want to get to the equation of a line, which is the equation y equals m, which is our slope, times x plus b. So our slope and our y-intercept. Okay. So to solve this, we'll use our value from the last term. We've got our 14.29. So we can say y equals that 14.29 times x plus b. And we're going to pick any one of these points. I'm going to pick this value for our x and y. And we're going to plug them in for x and y. So we get 100 equals 14.29 times 6.8 plus b. And now we can rearrange and solve for b. I'm going to take 14.29, multiply it by 6.8, and I get 97.172 plus b equals 100. I'm going to subtract the 97.17172 from both sides, and we'll be left over with b equals, so 100 minus 97.172, and we get 2.828. And so our answer for the equation here, we can say that y equals our 14.29x plus 2.828. So on this one, we're using the same problem as the previous one. Jumping back, remember we've got this value. On question number 3, it asks us what is the y-intercept from that equation. So if we had that equation again, y equals our 14.28x plus our 2.828, the y-intercept value is this value. So we can say our y-intercept is 2.828. All right. In this equation we have our voltage and our current, and we can label it as our x and y. We've got a table that has the values 2, 4, 6, 8, and 10 that we're plugging in for the v inside of this equation, and we want to solve for what the y is. So we're just going to use our calculator to set this up. We're going to take our value, and I'm going to just put 00 for our first value. So this value here, 0, 0 over our 1.6, and we'll divide it by 1.6, and we get 0 for that. Then when we replace this with 2 on the calculator, I can just hit up, go to 2, replace it, and I get 1.25. When we put in 4, we get 2.5. When we put in 6, 3.75. We put in 8. We get 5. And then when we put in 10, 6.25. Okay, so this version, they want us to graph. We're going to bring this up here. So we want to graph the linear equation. I'm going to add just a new blank space here for a second. Okay, so if we are graphing this, we've got our x-axis, which is also the I, our y-axis, which is also the v, and we start off at 0, 0. And then on here we go out to basically 7, so we can give ourselves 1, 2, 3, 4, 5, 6, 7. And then on here we're going up to 10, so we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0, 0 is our first point. 1 1/4, we go up to 2. And then we have at 2 1/2, we go up to 4. And then 3 3/4, we're up to 6. And then we're 5, 1, 2, 3, 4, 5. We're up to 8. And then 6 1/4, we're up to 10. And this gives us roughly a straight line if we sketch that in. Looks like we're looking at that last problem, and they want us to calculate the slope of a line. So let me just give ourselves two values again. We'll do the V and I, and let's do 2 and 4, and just re-plug those in. So at 2, we're 1.25. And at 4, we're at 2.5. So they want us to find the slope of this line. And we're going to just solve for the whole equation for the line. The y equals mx plus b. So first for our slope, for m, that's our slope, we can take y2 minus y1 over x2 minus x1. So we're going to do, this is our point number 2, or point number 1. So y2 is 4, y1 is 2, x2 is 2.5, and then x1 is 1.25. So solving that, we can do 4 minus 2 divided by 2.5 minus 1.25. We get 1.6 for our value, which is our m value. So I can say y equals 1.6 x plus b. I'm also going to plug in and solve for b, so I can say my 4 value equals 1.6 times my x value, 2.5, plus b. 1.6 times 2.5 gets me 4. If I subtract 4 from both sides, b equals 0, and so my equation then becomes y equals 1.6 x plus 0 for my y-intercept. So for this equation here, our slope we wanted is this value. For the next one, the y-intercept, it is 0. So we can say the y-int equals 0 based off of that last equation we solved. Okay. Our next problem says that we've got a truck. It's been purchased for this amount. They figure that they're going to require so much per day in operating costs. What is the total cost of owning the truck on any day t, represented by a straight line? So we want to have an equation for a line. We're going to use the cost equals basically the maintenance, the slope, times the number of days plus the original cost of the truck. So our y-intercept value is going to be this value, the 26,625. Time is just going to be time, and then the cost per day is going to be $19.65. And so this gives us the overall equation for it. So our slope here is the $19.65. Our y-intercept is the $26,625. And our equation for the line is here. All right, we want to solve this for the equation for a line. So we want it in y equals m times x plus b format. So we're going to rearrange the equation. I'm going to subtract x from both sides. I get negative y equals negative x plus 8. I'm going to divide everything by negative 1. And we get y equals x minus 8. What is the slope of the line? That's the value in front of x, which is 1. What is the y-intercept? That's this piece here, which is negative 8. And it looks like for the rest, we're just calculating the rest of the equation. So we can take this, and I'm going to put 0, 0 in for my first value, times our... Sorry, let me rewrite this. We got our slope of 1 times our x value, which in this case we'll start off with 0, 0, and we'll subtract 8. Okay, so in this case we get negative 8 for our 0 value. We can hit our up arrow and we can put negative 3 in, and we'll get negative 11. We can put negative 2 in, we get negative 10. We put negative 1 in, and we get negative 9. We can put positive 1 in and get negative 7. We can put positive 2 in and get negative 6. We can put positive 3 in and get negative 5. Notice with each of these steps we increase by 1, and each of these steps we increase by our slope value, which in this case is a positive 1. Okay, for this one we are going to evaluate this, and if we take negative 3/4 and we subtract 3, we get y equals negative 3.75. Our slope value, notice that we don't have any x value. We've got y equals 0 times x minus 3.75. So our slope value is 0. Our y-intercept value is negative 3.75. And because there's a 0 for our slope, any value we put in for x is going to give us the same y-intercept, negative 3.75, negative 3.75, and so on for all of these. Okay, this equation we are going to rearrange it. So we're going to subtract 3x from both sides. We get y equals negative 3x minus 5. What is our slope? Negative 3. What is our y-intercept? Negative 5. Let's plug it into our calculator. So we'll take negative 3, parentheses 0, 0, minus 5. And for our 0 value, we get negative 5. We'll put a negative 3 in. Oops. And we get 4. We put a negative 2 in. We get 1. Notice from here to here, we decrease by 3, which is our slope. We put a negative 1 in. We get negative 2. Once again, we decrease by 3. We decrease by 3. So our next value would be negative 8, then negative 11, and negative 14. We can double check that last value. Check that last value, and there's our negative 14. On this one, we are calculating our equation again. So now we need to find our slope. So m equals our y2, which is 4, minus our y1, which is 0, over our x2, which is 0, minus our x1. So with this problem, we can find our slope by taking the y2 minus y1 over x2 minus x1. Notice those added to negative. We get a 4 over 1 for our slope. For our y-intercept, so our slope is 4, or 4 over 1. Our y-intercept will solve the equation y equals 4x plus b, and we'll plug in one of these 2 points. I'm going to use this value. So 4 for our y equals 0 times 4 times 0 for our x plus b, and b becomes 4. So our equation is y equals 4x plus 4, making our y-intercept 4. And on our equation, we can clear everything out. We can do 4 parentheses 0, 0 plus 4 and verify that that is our intercept here. We can plug in a -3 and we get a -8. We can plug in a -2 and we get a -4. And so you can see for each one of these jumps it's increasing by the slope. So our next value will be 0. Notice it matches up with our point. 0 to 4, 4 to 8, 8 to 12, 12 to 16, and that's the rest of our table. Okay, next page. Okay, similar approach. We'll find our slope. M equals 4 minus 1 over 1 minus a -3. That gets us 3 over 4, which is also 0.75. So we can write our slope as 3/4 or 0.75. Then our y equals our slope 0.75 times x plus b, and we can plug in this value. So 4 equals 0.75 times 1 plus b, and we can subtract 0.75 from both sides. So if we take 4 minus 0.75, we get 3 1/4. So b equals 3.25. And our y equals 0.75x plus 3.25. We can plug in our value. So 0.75 parentheses 0, 0 plus 3.25, and we get 3.25 here. And we can put in our -3. We're starting with 1. Put in our -2. We get 1.75. Notice it's increasing by our slope. Put a -1. We get 2.5. Put in a +1. We get 4. +2. At 4.75. And a +3. We get 5.5. Okay. Okay, our slope here, 9 minus 5 over 3 minus 1. This becomes 4 over 2, which is 2. So m equals 2. Y equals 2x plus b. We'll plug in this value. So 9 equals 2 times 3 plus b. subtract 6, and we get b equals 3. So our equation y equals 2x plus 3. And we'll plug that into our equation. So 2 parentheses 0, 0 plus 3. So we get 3 here for our value. If we do negative 3, we get negative 3. Do negative 2, we get negative 1. Do a negative 1, we get a positive 1. And so realize each jump we're adding 2. So this would be 5, 7, and 9 for our value. We can check that last value, 03, and indeed it is 9. All right. Rearranging this equation, we're going to subtract 4x from both sides. So we get 8y equals negative 4x plus 16. Divide by 8. And that gets us y equals negative 0.5 x plus 2. Our slope, negative 0.5. Our y-intercept, 2. And we can plug in our values and see negative 0.5, 0, 0 plus 2. And so we get 2 for our value. Notice that the y-intercepts always match up as well. We can do negative 3. We get 3.5. Put in a negative 2. We get 3. And so notice that we are decreasing by 0.5. So this will give us 2.5, 2, 1.5, 1, and 0.5. And we could check that last value and verify that that is indeed accurate. Okay. For this one, we're going to subtract 3x from both sides. We get 3y equals negative 3x plus 18. Divide everything by 3. We get y equals negative x plus 6. So our slope is a negative 1. Our y-intercept is a 6. And if we plug this in, negative 1 times 0 plus 6. And we get a positive 6 here. If we plug in our negative 3, we get 9. And negative 2, we get 8. Notice with our slope we're decreasing by 1 each time, so 7, 5, 4, and 3. And if we plug in a positive 3, it checks out. Okay. And our last problem. We'll subtract x from both sides. We get negative 2y equals negative x plus 6. Divide by negative 2. And we get y equals 1 over 2x minus 3. Our slope is 1 over 2, or 0.5. And our y-intercept is negative 3. We can plug this in on our calculator. So 0.5 and then minus 3. And we get negative 3 for our y-intercept. Put in a negative 3 here, we can get negative 4.5. Put in a negative 2, we get negative 4. negative 1. We get negative 3.5. So realize we're adding 0.5 with each step. This is give us negative 2.5, negative 2.0, negative 1.5, and we'll verify that last value. And there we have it. And that is the end of chapter 13.